Here, for isochoric process, we'll study three things about this process. First one will be the definition of isochoric process. Then we'll apply first law of thermodynamics to isochoric process. And then we'll be calculating the work done during isochoric process. So first we'll see the definition, and it is somewhat like this, that when in a process the volume of the system remains constant, then such a process is called isochoric process. Now we'll apply first law of thermodynamics to isochoric process. So see, this is the mathematical form of first law of thermodynamics. Now for isochoric process, the volume remains constant, means dV, the change in volume, is equals to 0. So when I substitute this in the mathematical form of first law of thermodynamics, then this quantity becomes 0. So I can say dQ is equals to du. So from this, what I can say, the amount of heat energy absorbed by the gas is completely used in changing the internal energy of the system. And when internal energy of the system is changing, it means that definitely the temperature of the system also has changed, because internal energy completely depends on temperature. So when isochoric process, during isochoric process, if I apply first law of thermodynamics to it, I can see that the heat energy absorbed by the system is completely used up in changing the temperature of the system, and so changing the internal energy of the system. Now if I want to calculate the work done during the isochoric process, then see, in this equation, this P dV is actually what? This is work done. I can write this equation like this also. dQ is equals to du plus dW. ऐसे भी लिख सकते हैं हम. So ये dW हमने किसके लिए लिखा है? P dV के लिए. So P dV is equals to actually work done. But this dV is equals to 0 for isochoric process. So work done is also 0 during isochoric process. Now same way we'll study isobaric process. So first of all, its definition, then we'll apply first law of thermodynamics to it, and then we'll calculate the work done during isobaric process. So first of all, we'll see the definition of isobaric process. It is a process during which the pressure of the system remains constant. Now we'll apply first law of thermodynamics to isobaric process. So again, we'll start with the mathematical form. So this is the mathematical form of first law of thermodynamics. Now, see here what is happening. The pressure is remaining constant. The change in the volume dV, delta V अगर आपको लिखना हो तो आप कैसे लिखते हो? V2 minus V1. So change in volume can be written like this. These terms remains as it is. Now, from ideal gas equation, PV is equals to mu RT. What I can write? P dV is equals to mu R dt. If I want to see here change in volume, then this mu and R, they are constant. This is number of moles. This is gas constant. So यहाँ change मैं किस में देख पाऊंगी? Temperature में. If I change the volume, then temperature of the system will change. Pressure will remain constant, as this is isobaric process. So instead of PV, I can write mu RT. So this was P into V, P dV. So instead of that, I can write mu R dt, delta T, right? Delta T is what? T2 minus T1. So इसमें से ये step कैसे आया? By using ideal gas equation. So अगर आप ये वाला equation देखते हो, when first law of thermodynamics is applied to isobaric process, then what you can say is the amount of heat energy absorbed by the system partly increases the internal energy of the system and partly is utilized in doing work. So जितना भी amount of heat energy gaseous system ने absorb किया था, उसकी help से ये heat energy को उसने किस में convert किया है? एक तो internal energy में, और दूसरा part जो बचा था heat energy जो उसने absorb की थी, उससे क्या perform हुआ? Work perform हो गया है. अब अगर मुझे work done calculate करना है during isobaric process, then from here only I can see work done का formula क्या होता है? dW is equals to PdV. But PdV is equals to what? PV2 minus V1. So I can say that this is the work done during isobaric process. Now we'll see cyclic process. So again, we'll see its definition, then we'll apply first law to it, and then we'll check the work done during the cyclic process. So see here, The cyclic process is actually a process which does not change the initial state of the system. एक प्रोसेस तो हो रहा होता है, बट एज सुन एज द प्रोसेस गेट्स ओवर द सिस्टम रीचेस बैक टू इट्स इनिशियल स्टेट, जहां से शुरू हुआ था उसी स्टेट पे हमारा थर्मोडायनेमिक सिस्टम पहुंच जाता है. ओके, so such a process is known as cyclic process, in which the system returns back to its initial state. And whenever this happens, what will be the case? The internal energy will remain constant. Change in internal energy will be zero. Why? Because internal energy is a state function. It depends on the state of the system. And in cyclic process, the state of the system is not changing. जहां से शुरू किया था वहीं पर ही वापस आ गए जब प्रोसेस खत्म हुआ. तो फिर इंटरनल एनर्जी तो स्टेट पे डिपेंड करती है, तो इसलिए इंटरनल एनर्जी में कोई चेंज नहीं आएगा. इट विल रिमेन कांस्टेंट. नाउ विल अप्लाई फर्स्ट लॉ टू साइक्लिक प्रोसेस. So this is the mathematical form of first law of thermodynamics. And if delta U is equals to 0, change in internal energy is 0, then here instead of this I can substitute 0. So I'll get delta Q is equals to P delta V. So from this equation I can say that the total amount of heat energy absorbed gets converted into work done. So इसी में से ही मुझे वर्क डन ड्यूरिंग साइक्लिक प्रोसेस भी पता चल गया कि जितनी भी हीट एनर्जी हमारा सिस्टम एब्जॉर्ब करता है वो सारी की सारी किस में कन्वर्ट हो जाती है? वर्क में कन्वर्ट हो जाती है.